Hello everyone, this is lesson 11. We are talking about simple interest and compound interest. So I wrote down here simple interest, simple interest about it's calculated only on the initial principal amount of a loan or investment. What's the compound interest then? Already. Compound interest is calculated interest on both the initial principal and on the cumulated interest from previous periods, right? So we understand what is the simple and compound interest, right? Okay, we have simple interest formula. They're using first letter I here, and then P or T means that P, principal, means that starting amount, right? And R, annual interest rate in decimal. So we learned one question before, the rate of rate was percent. We were using percent before, right? This one we have to change in decimal. Okay, T is time in years. And then we have simple interest feature value. Then I don't know why they're using S. So maybe first letters, but I don't think so here, right? Okay, anyway, how? S equal to P plus I means that P stands for principal and I stands for the interest, right? Okay, now we have a future value and one is a periodic compound interest, continuously compound interest. So in the compound interest, we have two kind, right? So one is a periodic, one is the other one is continuously. So those their difference is how frequently interest is compounded over time. So let me write down the periodic one, the compounded at regular intervals, like a month or year. Let me write down. I should have wrote down earlier, right? So periodic, so compounded at regular basis, interval. So example, month or year, and so, right? Okay, continuously. So compounding, this one, compounding happens infinitely often. So we might think about discrete number, right? For the periodic and continuous number for the continuously compounded interest. Okay, so discrete number like 1, 2, 3, 4, and continuous number like a decimal. Okay, all right, so let's do two problems here. So first one, a recent college graduate got $2,000 signing bonus with her new job. She invested the money for 6 months in CD, paying 9% simple annual interest. They said a simple annual interest, right? So we are using simple interest in that case. So I equal to PRT, which is P is the principal, R is the rate, T is time, right? In years. Okay, so in the case, how much interest did the graduate earn? So interest, right? So we want to find out I. Now principal, which is 2,000, and R, which is 9%. So we make a decimal point here, pretend decimal point there, and then move to the 2 decimal point to the left. So 0.09. I used to teach this one as Beyonce method because she was singing to the left, right? To the left, la 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 la, to the left. Melody is so weird. But you guys don't know about the song, right? Okay. So we have a percent, we want to convert to the decimal. We make times 0.01 means that we make a decimal point, move decimal point to the left twice, right? So we have a 0.09. Okay, so we have that 0.09. Then the T times 6 months. 6 months corresponding 12 months. 6 over 12 is okay. All right. Now, if we calculate everything, we get 90. So it's dollars, right? So interest is $90. Okay, second part. How much money did the graduate have at the end of her 6 months investment? So S equal to future value, simple interest, P plus I, then principal was 2,000. Interest we just found $90, which is $2,090. Very good. Yeah. Okay. Now, let me bring this one here. Oh, no space. So we have this. Kelly borrowed $1,000 at 17% simple annual interest for 2 months, so she could pay her rent while she was between jobs. How much interest did Kelly need to pay? Basically same, right? Same as earlier. So I equal to P or T. So we want to find what's interest I. So initial amount, so 1,000 principal, and 17%, which is 0.17, and the time 2 months corresponding 12 months, right? If we calculate, there will be $28.33. Okay, second part. How much money did Kelly need to give the lender to pay off the loan? Same as earlier, so future value, P plus I, so there will be initial amount plus the interest. So she has to pay $1,028.33. Okay, everything is money, right? Okay, let's move on. So we have a chart here. Compound interest, what is it? Okay, now the first column talk about the simple interest scenario. Second column say the compound semi-annually scenario, right? Okay, now let's using the formula. So I introduced you the formula earlier. about the simple interest, which is interest I equal to PRT, and feature value S equal to P plus I, right? Now, how about compound? Compound here. So they don't say that continuously. So we think about this as a periodic, okay? If they don't say in the statement continuous, then we are using this one, all right? So let me copy this one. So here, so P is the initial amount, principal, and the R is the rate in decimal, M is the month, right? Times, right? And then T is also times years, right? So there we go. The M is number of compounding periods per year. So they say that 6 months compounding, 12 months compounding, like that, okay? All right, now, let's finish the simple interest first because we just did. Okay, first one. I equal to P or T. Interest is the 1,000. The rate is 0.04. 4% is 0.04. And the T is 6 months. So 6 corresponding 12. If we calculate, we get 20. And S equal to P plus I, which is the initial amount was 1,000 plus 20, which is 10, 1,020, and 20. Okay, second 6 months, same, right? So I equal to 1,000. It's the same, so let's go using I equal to 20. Okay, S equal to principal. So we have 1020 plus 20, this interest here, right? Okay, so we have this one, we have this one, so we have a 1040. Okay, this one is the same, interest is 20, S equal to 1040 plus 20, which is 1060, and I equal to 20, S equal to 1060 plus 20 equal to 1080, I equal to 20. Oh, can I move? Hold on a second. Okay, now I can move. S equal to 1080 plus 20, which is, oh, cannot think. 1100, yeah? 1100. Okay, I equal to 20, S equal to 1100 plus 20, which is 1120. Okay, so this is for 3 years. So if we invest $1,000, 4% interest for 3 years, then we earned with interest, with the initial amount, we get $1,120 after 3 years, right? Okay, let's do compounding. Compounding, we have semi-annually, means that annually is 1 year, right? But semi-annually is 2. is 2. Okay, we are using this formula. So S equal to principal P, which is 1,000, 1 plus R, which is 0.04, over M. M is semi-annually, so it's 2. And let's talk about the T. So they say that M times T, right? So M, which is 2, because this is the M, right? This is the M. And T, let's make a T. T is first 6 months. So 6 over 12, right? So we have times 6 over 12. Okay, if we calculate this one, we have 1020. All right, so we write in same 1 plus 0.04 over 2 because semi-annually, and then 2 times, and T equal to 1 because second 6 months, right? So this is 1 year. Second 6 months. This one 6 months. Okay, so if we calculate this one, we have a 1040.40. $1,040.40. Okay, now same 1,000, 1 plus 0.04 over 2, 2 times. Okay, so third 6 months, I want to express 1.5 year. Third 6 months. So if we calculate this one, 1061.21. Okay, next one, same, 1,000, 1 plus 0.04 over 2, and fourth 6 months means 2 years, right? 2 times 2 years. Then if we calculate, that's 1082.43 cents. And same 1 plus 0.04 over 2, 2 times 2.5. Now we understand fifth 6 months. So if we calculate this one, 1104.08. Okay, last one, same. It's 3 years. 2 times 3 years. Okay, so if we calculate, this is 1126.16 cents. So $1,126.16. So has a little bit, almost the same, but in that case, they invest only $1,000, right? So if you invest more, compounding has better interest, right? Okay, let's take a look this one. So compound interest situation. All right, So we have a couple has $30,000. They can invest at 8% compounded monthly. That's periodic, right? Because monthly, the interval, right? So, and also they don't say that continuously, right? So periodic, that's why they're using this formula, right? So monthly means M equal to 12, right? Means M equal to 12. Okay, let's do it. So S equal to P principal $30,000. Okay, 1 plus, and the 8%, we know this is a 0.08, 0.08 over M equal to 12. So we have a 12. And then what's the T? T equal to 3 years, right? So T equal to 3 years. T. Okay. If we calculate this one, we have $38,107.11. Okay, how much interest did they earn, right? So this is the interest, right? So, I mean, they make money this much in 3 years. So we want to calculate the interest. So $38,107.11 minus initial amount they invest. So $30,000, right? So if we calculate this one, $8,107.11. Okay? All right, second part. The couple need $45,000 for down payment on a house. How many years would it take for their money to grow to $45,000? So we set up $45,000 other side. Then we calculate for T, right? Okay, second part. So 45,000 equal to 30,000, 1 plus 0.08 over 12, and 12T. Then solve for T. Okay, then first of all, we divide by 30,000 both sides. Then there will be 1.5. 1 plus 0.08 over 12 to the 12T. Okay, now we can calculate the inside the parentheses, or we can bring down the power. We can do that too. How do we bring down the power? We take the ln, or we take the log of both sides. So let's do it. So take the ln both sides. So there will be 1.5 equal to, and we have inside will be 1.00666 12T. So since we will take the ln, so it will be ln 1.5 natural log, right? 12T natural log of 1.00666. Okay, now we divide by let's do that. 12 natural log 1.00666 natural log 1.00666. Okay, then t will be, is correct, right? So t will be is 5.09, which is 5 years. Okay, let's move on. We have this one. What is continuous compounding? So suppose you invest $1 at 100% interest for 1 year. In that case, principal initial amount, which is $1, and the rate is decimal, which is 1 as well, and then t equal to 1, right? Annually is 1 year, right? So we have 1, and then m equal to 1 here. This is m. Then 1 times, so we get 2 if we calculate. All right, now monthly, then it's 12. So we are using 12 for the m and 12. Since t equal to 1, we don't use 1, right? Multiplication. Okay, so they omit t here, right? Because 1. Okay, daily, 365 days. So m is here, 365. And then we are using as a power as well. So number is here. Hourly. So hourly, how many hours? 24 hours times 365 days. That is 8,760. They got that, right? So m is here, and then we are using as a power. Okay, each minute. So we have 60 minutes and 24 hours and 365 days, yeah? Then we get 525,600 there. Okay, each second. So second, 60 seconds. So we have a 60 second times how many minutes? 60 minutes and 24 hours and 365 days. So we calculate it's 31 millions 536,000. Okay, now we are using the compounding interest formula. So it will be 1 plus 1 over that number. And then we are using as a power. Then we get 2.71828. All right. Okay, we have 2 more example here. So we did that earlier, compounding periodic. So we are using the formula. This time we have compounded interest continuously. Okay, let's take a look. To help their child buy a car on their 16th birthday, parents invest $7,500 on the child 10th birthday if the investment pays 9% compounded continuously, right? So continuously, so that we can use the formula, which is S equal to P, P as a principal, initial amount, and then we are using E. E is the number, right? So E is, we introduced E was 2.718281 and so on, right? Okay, and the R as a rate in decimal and T is a time, year, right? Okay, now we are using S equal to P, which is 7,500, and E to the initial, the rate, 9%, which is 0.09, so 0.09, and T, which is 16th birthday, right? 16th birthday minus the 10th birthday, so it will be 6, so it's 6 years. So if we calculate this one, it's not 1,000, $12,870.05. Okay, what a lucky child, right? Okay, next one, new grandparents wants to give $50,000 to their newborn grandson on his 18th birthday to help pay for college, right? Number one, how much do they need to invest now if they can earn 11% interest compounded continuously? So continuously only, again, not only. So we are using this formula, S equal to P, E to the RT. Okay, now the initial amount will be 50,000, E to the R. R is 11%, so 0.11. And then year, this is T, yeah? T equal to 18 because newborn. And the 18th birthday, right? So 18. So if we calculate, we have wait a minute. Sorry about that. Habit, right? So hold on 1 second. They want to give it to the $50,000, right? So it should be other side. And then they want to know how much they need to invest to earn $50,000 on his 18th birthday, right? Okay, heavy. So let me using this one other side. And we want to know about the P, the principal initial value, right? Okay. We want to calculate, we want to divide by e to the 0.1118, both sides. So this is approximately 7.2427. Okay, then P is $6,903.50. That's the initial amount, principal, they have to invest to give it to their grandson, right? $50,000 on his 18th birthday. Okay, second part. How much interest will they earn? So, second part. So they have in the case $50,000, and then they will earn, right? $50,000. And then they invest 6,903.50. Then the amount is 43,000. Wow, that's too much. Oh, that's a lot, right? That's for interest, right? That's for 18 years, almost 20 years. Invest almost $7,000. Then they can earn $50,000 at the end. Okay. Thank you for watching. See you. Bye.